Good afternoon, everyone, and welcome to the DHS2 live demo. Let's get started with a small agenda here. The objective today is to showcase the new implementation of DAFNE for data flow visualization and compatibility with intelligent synchronizers. The DHS2 version of DAFNE includes a new set of features for collecting and visualizing metrics related to the DHR services, including service availability visualization, publication latency visualization, data visualization. First of all, we need to collect the measures of the front-end service of the local center.
Sorry, Arturo, maybe we missed some slide, the previous slide.
Okay. Sorry.
We missed you for a while you were talking about the features.
No problem. Thanks, Christina. I repeat. So let's start again. The DHS2 version of DAFNE includes a new set of features for collecting and visualizing metrics related to the DHR services, including service availability visualization, publication latency visualization, and data visualization auto refresh. Before run the live demonstration, let's talk briefly about the implementation behind the scene about the service availability visualization and publication latency visualization. So the needed steps. First of all, we need to collect the measures of the front-end service of the local center at a configurable schedule time, which is by default set to every 10 minutes. Front-end service in this context, in the DAFNE context, is the DUS front-end, the DUS catalog, which is basically the system that exposes the products to the end users. So we need to visualize the availability of this kind of service. Once we have collected the measurements of this front-end service, we need to group them by date for a given data range in a maximum rolling window of 31 days. And then we have to roll all the measurements older than configurable number of days, which is a configurable parameter as well, set by default to 90 days. And finally, we get something like this screenshot. We'll see more in detail during the live demonstration. And let's move on the publication latency visualization. First of all, also in this case, we need to collect the measures of the backend services of the local center at a given time, which is by default set in this case to every hour. Then we group as for the service availability, we group these measures by date for a given data range for a maximum of 31 days in a rolling window. It is possible to show also details about the publication latency for a specific date. In this case, the default value is set to hourly. So the data, the collected data, can be visualized, grouped by hourly. And then we also, in this case, we roll these measurements all the measurements older than a configurable number of days, which is by default also in this case set to 90 days. Probably about publication latency, we need to clarify more in details the algorithm behind the scene. First of all, we retrieve the synchronizer configured in the backends of the local center. Then we retrieve the more recent creation date for each synchronizer. Then we try to identify the last product synchronized in the data source according to the previous retrieved date, creation date. Then we retrieve the corresponding product synchronized in the backend instance associated to the local center, and the corresponding product synchronized in the front-end instance. And then finally, we can compute the publication latency as a difference between creation date of the product on data source and the product on front end. From an operational point of view, in this case, we have to manage some special cases. Just for example, if a product identified on the backend is not found at the first attempt on the front end, DAFNE supports a retry mechanism, which is configurable in terms of maximum number of retries and frequency for each retry. For example, 5 retries, each retry is every 10 minutes. And this process is running completely in the background. But if the product is not found in the front end after this number of retries, DAFNE reports the timeliness computed with respect to the backend. And this behavior, this information is reported on latency chart, just to inform, just to notify the end user that the computation is coming from a backend and not from front-end side. And finally, we get something like this, a chart that we see more in detail during the live demonstration. Let's move on. Data visualization, auto refresh. Starting from this release, any data flow changes are visible in DAFNE without the need to refresh the browser. The updating frequency is a configurable parameter which is set by default to 5 minutes. And this is not applicable to completeness, publication latency, and service availability due to computational cost of these kind of metrics. Intelligent synchronized compatibility. DAFNE, starting from this DHIS2 version, supports OData version 1 and OData version 2 APIs in terms of data flow visualization for data sources and DHIS connected info. Basically, all information in the panel and over the map component. DAFNE supports the automatic detection of legacy or intelligent synchronizer associated to the backends of local center. And about configuration management of synchronizer, in this context, configuration is defined as creation, deletion, or modification of intelligent synchronizer. In this case, this is supported currently only for this version less than 3.1.x. Anyway, the user will be notified in case of different this version. So for this version greater than 3.1.x, currently DAFNE doesn't allow to start, to stop, or to edit a synchronizer. In order to show this compatibility during the demo, we have prepared three different scenarios, operational scenarios. Starting from scenario one, we have here a local center, which is composed by this front end that is synchronized with this front end, and we have three different data sources, remote data sources, in this case, three collabs instance, synchronizing with our DUS backend in local center. And we have a new instance here, named here DUS Intelligent, which is DUS version 3.1.x. In this case, this version, this instance is acting as a backend of our local center. So what we expect to see over the map is to have three different arches, three different remote data sources, and just one connected DHS. Let's move on scenario number two. In this case, basically it's the same scenario as before. The only difference is that in this case, our DUS Intelligent instance is configured as an additional remote data sources. So what we expect to see over the map is to visualize four different arches connecting the remote data sources with our backend in the local center. And finally, third scenario is a little bit more complicated. In this case, we try to configure the DUS instance, a DUS Intelligent instance, as an additional backend inside our local center. So we will see in the map three different collapse instances and two additional synchronizer. This instance will be configured as with an intelligent synchronizer multi-sources. In this case, this intelligent synchronizer is configured with two different center, API Hub and Sci-Hub. And what we expect to see in the map is to have 5 different arches connecting remote data sources with our backends in this case. So let's start live demo here. Okay, so as usual, all the new functionalities are reachable from here on the top right of the application in the main menu. So we have added here service availability and propagation latency, and we have added this functionality also here on the left panel of the DAFNE, just to simplify the user experience, a sort of shortcut for the functionality. Let's start with service availability. So we can launch here, and the main chart appears. In the center, we have the chart. On top, we have here just a couple of fields to select a time range. And here we have in the legend the thresholds and colors, which is the set by default as the value coming from the defined KPIs, but these are completely configurable. So in case of I don't know, a particular need to change this threshold or color, it is possible. Simply changing this value in the configuration file. Below here, we have the tabular representation of the data coming from the visualization. So let's try to select here just a range, and the chart appears here. We have, in this case, a simple bar chart. Every bar here is for day, and the color of this bar is the same as reported here in the legend. The horizontal lines represents the thresholds. And in case you need a more room here, it's possible click on this handle just to maximize the chart here, and it is possible to change the visualization, switching from bar chart to calendar chart, which is basically the same data represented in a different way. So we have for every day reported here the value or percentage and the color as defined in the legend here. It is possible to export also these kind of data, in this case through the browser menu here. It's possible to save this image, or it is possible to export this tabular view of data in a comma separated value file in CSV, and by clicking here just to show the file. And in this case, we have established a sort of naming convention for the file. Here we have application name, type of service, name of our local center, and time range. And this is a separated value file, basically. I don't know, in case of further processing, I don't know, just for reporting, or it's possible. It is useful to export this data. Here are reported in the first row the total request that the backend side of DAFNE sent to the front end, DUS front end in this case, and in the success, and also in the second line here is reported the success responses of the service. Basically, the request we do here in this context is an HTTP request. So we need to catch the response of this HTTP request, and in order to check if an external remote service is online or offline. So in this case, we have a value not fully percentage here. In this case, we have made some requests, but we have a minor number of successfully responses. So In this case, this percentage is near the 100%. Or in probably some worst case here, the service is completely down for the year, for 1st June. And it's possible to zoom in, zoom out, double click to reset the view, and here is reported also the average value computed based on this data set collected here. And basically that's all for service availability. Let's move on publication latency here. Basically, we have here the same graphical user interface, the same component. A small difference here is that we have the possibility to select different synchronizer. For example, if I select this sync and I choose probably not the best situation here because we have almost all red data. Is possible, as I said before, for a specific day, is possible to, with just a click, to show the detailed data grouped by, in this case, hourly. So in this case, we have all the data collected in this date. And if I choose different situation here, or Sentinel-1, in this case, as I said before, the information computed by DAFNE on the value based on the backend side is reported here just with this small string here, this small tag here, just to notify that this data is coming from the backend. For the backend side is has been used for the computation. Also here, it is possible to click and open a chart representing the detailed view grouped by hour in this case. And it is possible to switch to a different chart here, in this case a line chart. And also for the publication latency is possible to maximize the charts on the zoom in or zoom out, and it's possible to export this data in a comma separated value file. And I think that's all for this kind of metrics. So let's move on the intelligent synchronizer compatibility. We have identified 3 different scenarios. So let's start with scenario number 1, where we have 3 different collab instances configured as a remote send and just one connected DHS. So starting from here, the info reported here in data sources, we see that we have 3 different data sources, and we can show on map, click on this button, and we will see that we have 3 different arches. In this case, also the color helps to us to identify the data flow. In this case, the green data are coming from Colab 3 to our DUS local instance. So this is showing that we retrieve data. We are retrieving data from this instance. The same for the pink, for the light green here. And as reported also here on the left panel, the DHS connected, we have just one instance connected here. So if we show it on the map, we noticed here that we have DUS Smart. So we named here DUS Smart. That in this case is retrieving data from our DUS local. So the green data is coming from DUS local to our DUS Smart. So in this scenario, we have a new fresh new instance of DUS 3.1.x that is retrieving data from our DUS local. So we, in this case, we through DAFNE, we can visualize the compatibility with the intelligent sync. Scenario number 2, just a small difference here, where our instance of this intelligent is configured as an additional remote data sources. How do we change this behavior inside the DAFNE? As you can see, it's just a matter of configuration editing. In fact, we need to change the behavior of a configured center. Clicking on, in this case, our DUS Smart, we change this service type from backend to front end, then submit this update. And what we expect to see is an additional data sources info here, but it is not visible yet. So we have to check, in this case, the synchronizer panel, just to check if everything is running okay. And we notice that in this case, the smart synchronizer is stopped, as reported here in the status column. So we can run, we can start the synchronizer. The status now is pending, which is fine. And if we come back to our main view, we see that we have an additional instance here, currently synchronizing all product types. And we can visualize over the map. And now a new arch appears here. And also, thanks to the color, we notice that this violet here is coming from, data is coming from this smart to our local instance. So my local center now has an additional remote data sources. So this local center, this DUS configured in local center, is a synchronized data also with this DUS 3.1.x instance. And as reported here, now we have exactly 0 DHS connected. So if we show on map, nothing appears. And third scenario, where we need to configure the intelligent instance as an additional backend, but in our local center. So let's make this change. In service panel, we try to change this configuration of this smart. First step, we needed to change the service type from front end to back end. But in this case, we need to link this instance to our local center. So we needed to specify as a center our DUS local instance. So backend of our DUS local. So we submit this change, commit this change, and now we notice that we have an additional data source information here, API, product type, and so on. And we have also the Sci-Hub instance here. So if we show on the map, we notice that we have two different remote center here. And due to the current limitation of DUS, today is not possible to distinguish between which of the multiple product data sources configured in the intelligence synchronizer is currently active. So now in this release, DAFNE will show both the product data sources of the intelligence synchronizer, but there is an ongoing discussion with Gael team in order to implement this type of flag through the OData API in order to allow to external services as DAFNE to check if a product source is active or not. So in this case, we just to inform you that today we show both the product sources configured in the multi-source intelligence synchronizer. And as I said before, if we open the synchronizers panel, we notice that the actions here are not currently developed. So the possibility to edit the configuration or to start and stop the intelligence synchronizer is not currently supported. While for the version less than 3.1.x is supported here. And well, I think it's that's all from our side. I don't know if you have any comments, any questions. Please do not hesitate to ask.
Yes, you could ask now, or in the chat if you want. You can write the question, yes. the clarification.
Yes, sure, as you prefer.
In the meantime, Arturo, thank you for the demo and also for the three scenario very clear that you presented. Okay, so if now there are no questions, you can ask any future clarification to Elisabetta and the support team via email or via Jira. And of course, the presentation will be uploaded in Jira, so you can also review the demo after the meeting. And thank you for the participation.
Thank you.
Okay. Okay, Julia, I think we can stop the recording.
Okay.